viewers to the first episode in a series of 11 episodes that are going to focus on the 2020 GCE Science Paper 2, which is Chemistry. So we are going to start with section A, where we are going to look at this section critically. So you notice that I may take longer time than you would take to answer this question in an exam, because I'm trying to give you the context and explain to you so that you understand what is going on. Once you understand and master the concept, you should be able to take less than half the time that I'm going to take to answer this section. So let us move straight to section A. Question A1. A sample of a pure compound is heated until it is completely molten, and the compound is then allowed to cool until it is completely solid again. The graph shows how the temperature of a compound changes with time. Which of the following shows points when the compound exists both in liquid and solid states? So both in liquid and solid states. So when it is completely molten, this is liquid state. So at N, this from N to O, this will be liquid state just after finishing heating it. Then this part, it will be in the solid state. Then up to here, then this will be a mixture, which is liquid plus solid state. So you see the range O to P. This is where we are going to have a mixture. So if you check the answers, you notice that B is the correct answer, which is O to P. Question A2. The diagram below shows one of the methods used to separate mixtures. The above method is, so what do we have? We have the beaker, which is A, then we have residue, which remains in the beaker, then we have beaker B, which are received these, then these are clear solvents. So what kind of method is this? A, chromatography. Chromatography is used to separate inks depending on their solubility. So A is incorrect. B, crystallization. This is not crystallization because we are not told that what is in beaker A and beaker B, they are sublimates or they undergo sublimation. So B is incorrect because this is a clear solvent. Then C, decantation. D, filtration. So if it was filtration, we are going to have a filter somewhere here, so it cannot be D. Decantation, this is the correct answer, which is C. So C is the correct answer. So if you look at decantation, so decantation, you use it to separate insoluble suspension that settles to form a sediment down. So this is the case where we are saying this is in residue, which are, these are sediments that you use to separate from the clear solvent. Hence decantation is the best answer in this case. Let us look at question A3. Which gas is not obtained on a large scale by fractional distillation? So you notice that A is the correct answer. A, you obtain it using the Haber process, which is ammonia. So it is the only common alkaline gas and make red litmus paper blue as the testing for knowing that this is ammonia. All these are separated by distillation. These are using the fractional distillation to be obtained from the common air. Let us look at question A4. A mixture of salt and iodine crystals was heated for 20 minutes as shown in the diagram below. what is R and S. So if you look at what we have salt and the iodine crystals. So when iodine crystals is heated, it's going to sublimate. So it's going to undergo the process known as sublimation, which is the direct change of state from a solid to a gas on heating, or from gas to a solid on cooling. So this will happen to iodine crystals, but this will not happen to salt. Salt, no matter how much you are going to heat it, it will remain as below here. It's not going to sublime. It's either going to start melting, but it will not sublime. So R will be the sublimate, which are the solids that are going to stick here once these gaseous iodine starts to cool down. So what will be now S? S will be the residue, what will remain here after the others go up. So S, they are not sublimates. Sublimates are R. So R are sublimate, which is only the B, which is correct here. Then this is the residue. So you notice that B is the correct answer. So you need to take note of the substance which sublime. So these are iodine, ammonium chloride, ammonium sulfate, carbon dioxide, which is also known as dry ice. So these are key substances that you need to take note of, because you might come across a question that will ask you to list these key substances that undergo sublimation. So take note of that. Question A5. Graphite and diamond are allotropes of carbon. Which of the statements below gives the correct meaning of the term allotrope? A. The existence of two or more atoms having the same number of protons but different number of neutrons. So this is what is known as an isotope. So this is an isotope, not an allotrope. B. The existence of different forms of an element but in the same physical state. So this is what is known as an allotrope. So the allotrope is the existence of different forms of an element but in the same physical state. If you look at C, they are giant structures formed from a network of carbon atoms. These are either diamond or graphite. These are what are known as giant structure formed from a network of carbon atoms. So this is just describing either graphite or diamond. D. Compounds having the same molecular formula but different structural formula. These are what are known as isomers. Question A6. The table below gives data about 4 substances. Which substance has particles in a disorderly arrangement at room temperature? So disorderly arrangement is a key term here. So disorderly arrangement happens in the gases. So now we need to identify which one is a gas in here. So room temperature, we have the melting point is in this case negative 114. Then boiling point is negative 80. So at room temperature, which is above 0 degree, this will be a gas. Then B 120 melting point, then boiling point 445. So at 445, this will still be in solid state, because this is way above the room temperature, which should be between 20 and 30 degrees depending on the region, or let me say between 10 and 30 degrees depending on the region. So this should be in the solid state. Then C melting point 750, then boiling point 1407. Again, this will be in the solid state. Then if you see this one, this is way above room temperature, it will also be in the solid state. So you notice that A is the correct answer in this case. Then A7, at which temperature does a concentrated aqueous solution of sodium chloride begin to boil? So again, you need to know what happens to ionic bonds. So you notice that this is the ionic bond. So ionic bonding have high melting and boiling points. This is because of the strong force of attraction between positively and negatively charged ions. So if you look at this one is below the boiling point of water. This one below water, it can't happen. Then this one is just at the boiling point of water, which is 100 degrees Celsius. So it has to be above 100 degrees Celsius. So it will be D. D is the correct answer. Just know that ionic bonding, they have strong force of attraction between positively and negatively charged ions. Hence they have got higher boiling and melting point. Question A8. To determine the concentration of an acid, a learner titrated hydrochloric acid against potassium hydroxide solution. She used 25 centimeter cubic of 0.2 moles per decimeter cubic potassium hydroxide. If she started titrating from 0.7 centimeter cubic and reached her end point at 36.2 centimeter cubic, what is the concentration of the acid? So the question is, we need to find the concentration of the acid. What is the acid? Hydrochloric acid. What do we have? We have potassium hydroxide, which is in the volume of 25 centimeter cubic. Then molarity, which is concentration, is 0.2. Then hydrochloric acid, we have the volume, which is 36.2, the final minus the starting point, which is 0.7 centimeter cubic. We are getting 35.5 centimeter cubic as the volume. What is molarity? We are not given. That's what we are looking for. So what happens if we react potassium hydroxide with hydrochloric acid? So the reaction will be hydrochloric acid plus potassium hydroxide. We are going to get a salt, which is potassium chloride, then plus water. So if you look at this equation, is this equation balanced? That's what we need to ask ourselves. So in terms of hydrogen, we have 1, which is 2 this side, then we also have 2. Oxygen 1 and 1 this side. Potassium 1, 1. Chlorine 1, 1. So it is a balanced equation. So we have mole ratio of 1 to 1. So we can now easily find the concentration of hydrochloric acid using two methods. So I'm going to give you two methods, then you are going to choose which one is quick. So using the mole ratio, what we need to do is now we need to find the number of moles that are in potassium hydroxide. So we know that molarity is given by the number of moles divided by volume. Then this volume should be in decimeter cubic. So how can you find the number of moles, which is N? The number of moles is equal to molarity multiplied by volume. So what is molarity? This is 0.2, as you can see from here, then multiplied by this volume in decimeter cubic. Because there are 1000 centimeter cubic in 1 decimeter, so we are going to divide 25 by 1000 to convert it to decimeter cubic. So it will be 25 over 1000. So we're going to get 0.2 multiplied by 0.025. Then what do we get? So we're going to get 0.005 moles. So these moles that are in potassium hydroxide are the same moles that are going to be in hydrochloric acid, because the mole ratio is 1 to 1. So now what we do now is how to find now molarity, which is concentration. It's in number of moles divided by volume. So number of moles is 0.005, then divided by the volume. This volume is now need to be converted to decimeter cubic. So what we are going to do is, let me use a different color, so it will be 35.5. We divide it by 1000 like we did here, then we are going to get 0.00355. so here we come and divide by 0.0355. so this is 10 here. Then what do we get? So we are going to end up with 0.140845, which is the same as 0.141 moles per decimeter cubic, which will notice this is B in this case. This is one method. So the second method is you find the number of moles in hydrochloric acid, you equate it to the number of moles in potassium hydroxide using this formula. So hence what you are saying is molarity 1 multiplied by volume 1. So this is hydrochloric acid. This must be equal to molarity of potassium hydroxide multiplied by volume of potassium hydroxide. Then you solve for this. So what you notice in this case is this will be this 2, then this one will be this volume that we had found, which is this one. So basically this part is this part. Then you equate to volume, which is this one, then you multiply by this m, then you solve for m1. You're going to end up with the same answer. So technically it's the same thing you're going to arrive at. Question A9. The energy level profile shows how adding substance X to a reaction mixture changes the reaction pathway. Which change occurs when X is added to the reaction mixture? So we have A, the rate of reaction decreases, B, the rate of reaction increases, C, the reaction becomes less exothermic, D, the reaction becomes more exothermic. So we need to understand some few facts about the reaction pathways. So the first thing that we notice here is we have two activation energy. And in the first place, what is activation energy? So activation energy is the minimum energy needed for reactant molecules to have a successive corrosion and start the reaction. So before the reaction starts, the molecules in the reactant section of the equation need to collide. So when they collide enough, they are going to start that reaction. Now that energy which is needed, the minimum energy, is what is known as activation energy. So we have two activation energy. Let me just draw this line. So we are going to have this line here, the reactant. So from here to the top, we have activation energy, which I'll call activation energy 1. Then also we are going to have this, which is in activation energy 2. So how do we tell whether the reaction is exothermic or endothermic? Is it more exothermic or less exothermic? So the reaction is said to be exothermic when the reactants are higher in energy than the products. That is exothermic. So at the beginning, you have more energy than you have at the end. In that case, we are talking about exothermic reaction. Then, on the other hand, the reaction is said to be endothermic reaction when the reactants are in lower energy than the products, meaning the energy was absorbed. So if the reactants have more energy than the product, it is known as exothermic. If the reactants have less energy than the product, it's known as endothermic reaction. So now what are we observing here? If you notice, the reactants have got this level of energy. That's what is we have here. But the products have got lower energy than the reactant. So the products have lower energy than the reactant, meaning the reactants, they have got more energy than the products. So we are saying without X, this is the energy. Then this becomes the energy with X. So by introducing X, the activation energy needed drops. But we know that this reaction in itself is exothermic because the reactants have more energy than the products. So this is exothermic reaction in itself. We know that. But because now the activation energy required without X has dropped to this level, just this level. So meaning this becomes less exothermic. It is still exothermic, but it is less because it's giving out now less energy than it would have going to give if we had not used X. Hence, you will notice that C is the correct answer. A and B, they are not correct because we are having the product almost at the same pathway, meaning the rate of reaction is not increasing or decreasing, so these are incorrect. So this is how you arrive at the answer, which is C. So key thing that we need to notice also is the transition state, which is the stage during the chemical reaction at which chemical bonds are partially formed and broken. So that is the transition state. Then the activation energy, like I said, is the minimum energy needed for reactant molecules to have enough cohesion to start the reaction. So take note of those key points. Question 810. When solid potassium chloride is added to water, the temperature of the liquid goes down. Which conclusion can be made from this observation? A. The potassium chloride molecules split into ions in water. B. The process is exothermic. C. The process is endothermic. D. Very little potassium chloride dissolves in water. So, if you look at this question critically, what is key here is the temperature of the liquid goes down. So if the temperature of the liquid goes down, what it means is the energy in the reactant is greater than the energy in the product. So if this is the case, we are saying this is an exothermic reaction. So the process is an exothermic process. That's why B should be correct. If it was the other way around, where the temperature of the liquid goes up, it was going to be the process is endothermic. We cannot determine whether potassium chloride is split into ions in water or not by just observing temperature. So A cannot be correct and also D cannot be correct. So the answer is B. Question A11. Which ionic equation represents the neutralization of sodium hydroxide solution with dilute sulfuric acid? So we need to identify which one of these is the correct ionic equation. So what happens when we react sodium hydroxide with sulfuric acid? So let us write this. So we have sulfuric acid, which is given by this, and this is aqueous. Then we react it with sodium hydroxide, which is also aqueous. We are going to get sodium sulfate, which is aqueous solution, then plus water, which is liquid. This is what we are going to get. So now the next thing that we need to do is to balance this equation. So how can we balance this equation? We notice that we have 2 hydrogen, then this side we have 2 hydrogen. So in terms of hydrogen, hydrogen is balanced. We have 2 to this side. So now next, let us try to see how we can balance sulfur. So sulfur we have 1 this side, sulfur is balanced. Oxygen we have 4 plus this one, which is 5. This side we have this one plus which is also 5. But when we look at sodium, this side we have 1, this side we have 2. So we can introduce a 2 here to see what happens. So once we introduce sodium here, we're going to have now 2 plus that, so oxygen is going to be 6. So oxygen is no longer balanced. Then the question is, how do we balance oxygen? So to balance oxygen, we need to introduce a 2 here. So once we introduce a 2 here, we're going to have 2 plus this side is going to be 6. Then this side it will be 2 plus this one is going to be also 6. But in terms of hydrogen, is hydrogen balanced? So hydrogen is also balanced because we are going to have these 2 times this H, it will be 2 plus 2, which is 4. So by introducing just 2 numbers, we balance this equation. So this equation is now balanced. So now, since we have the balanced equation, now we can break it down in the ions. So what we have, we are going to have 2 positive hydrogen because of here, then plus we come here, we are going to have this, the sulfate, an ion, which is with 2 negative, then plus we are going to have 2 sodium with the positive ion, then plus because there is a 2 here, so we are going to also have 2 hydroxide anion. Then this is going to equal to, this one is going to be 2 positive ions of sodium, then plus we are going to have the sulfate anion, then plus the new product, which is water. So this water is now a new product. We are not going to break this one. So what we notice in this case is this one and this one are the same, they cancel. Then this one and this one, they're the same, they cancel. So you're just going to end up with 2 hydrogen, then plus these 2 hydroxide ion. This is going to equal to these 2. There is a 2 here, remember these 2 that I forgot, so it will be 2 water, like that. So this will be the Ionic equation. So we come and check here, we notice that A is the correct answer. So this is how you answer question 11. Question A12, which of the following reagents could be used to distinguish between dilute nitric acid and dilute hydrochloric acid? So we have A, aqueous barium chloride, B, aqueous silver nitrate, C, aqueous sodium hydroxide, D, copper 2 carbonate. So it is important that you know these 2 methods that you use to distinguish between nitric acid and dilute hydrochloric acid. So the first method is you take the unknown acid and add a few drops of it to silver nitrate. So when you add that to silver nitrate solution, if the silver nitrate solution turns into white due to the formation of the silver chloride, then the acid is known as hydrochloric acid. If nothing happens, which means the solution remains clear, then the acid is nitric acid. Because what you notice, when we react nitric acid with silver nitrate, there will be no reaction. But when you react this hydrochloric acid with silver nitrate, there will be a double displacement reaction that is going to take place. So when you add the drops of hydrochloric acid to silver nitrate, this is what we are going to get. So we have silver nitrate, which is given by this formula. Then you react with hydrochloric acid. All these are aqueous. Then what we are going to get is, we are going to get silver chloride, then plus nitric acid. So this will be a white precipitate. So it's this one that we are going to use to distinguish nitric acid and hydrochloric acid, because when you add nitric acid to silver nitrate, the reaction will not happen, because this and this anions are the same. So that's the first method that you are going to use. What is the second method? So the second method that can be used is reacting hydrochloric acid with the metal and also nitric acid with the metal. So if the reaction with metal yields a brownish gas, then the acid is nitric acid, because that brownish gas will be nitrogen dioxide. On the other hand, if the gas has no color and makes a pop when a lit match is held up to the jar holding the gas, then the gas evolved is hydrogen, and that acid is hydrochloric acid. So take note of those two methods. Question A13. An aqueous solution of compound X reacts with sodium hydroxide solution to form a green precipitate. When aluminium 4 is added to the mixture and then warmed, a gas that turns damp red litmus paper blue is given off. What is X? A. Ammonium nitrate, B. Copper 2 chloride, C. Iron 2 nitrate, D. Iron 3 nitrate. So we have sodium hydroxide solution, we are adding to X, and we are trying to identify what X is. Then this forms a green precipitate. So a green precipitate is an indication that we have iron 2 cation in X, because sodium hydroxide solution is used to distinguish between solution containing iron 2 cations and the solution containing iron 3 cations. So when the solution contains iron 2 cations, it will form a green precipitate, while the solution containing iron 3 cation, when you add this sodium hydroxide, it will form a reddish brown precipitate. That's the distinction. So we know that it's not this one. Again, because we are getting this gas which is turning the red litmus paper to blue, so this should be ammonia gas. So if it's ammonia gas, meaning we have nitrate somewhere there. So because we have nitrate somewhere there, it means this should combine with the test for iron 2 cation, which is iron 2, which is this one, then also this one, nitrate. So you notice that C is the correct answer. Take note of the test for the cations for iron 2 and also iron 3. Question A14. The positions of 4 elements are shown on the outline of part of the periodic table. Element X has a high melting point and is a good conductor of electricity. It forms sulfates, which is sulfate 2 and the X sulfate 3. Which element is X? So what you can see from these two sorts of sulfates is this element is from the transition metals. So transition metals are in this ring. So you notice that C is the best answer in this case, because it cannot be A. If it was A, it was going to be like this. If it was B, it was just going to be 1, which is this sulfate. Then it cannot be D. Then question A15. In the laboratory, an experiment was set up as shown in the diagram below. Magnesium metal, then dilute hydrochloric acid. Which of the following is the correct equation for the reaction in the above experiment? So magnesium, which is from group 2, is a solid. Then we react it with hydrochloric acid, which is aqueous. So we're going to get magnesium chloride plus hydrogen gas. So this is what we're going to get. So we need now to balance this equation before we look at the answer. So we have one magnesium, then we have one chlorine there, but here we have two. We have one hydrogen, the other side we have two, so we can introduce a 2 here. Once we introduce a 2 here, we're going to have two hydrogen, two chlorine, like that. It is balanced. So now let us check. So if you see this one is unbalanced. Okay, correct but unbalanced. Then you look at B. This is not a gas because of here there is no, this is not a gas, so it's incorrect. If you look at this one is balanced and correct, so C is the correct answer. A is correct but it is unbalanced, so make sure to go for the one which is balanced. This one is not the correct formula for magnesium chloride, so D is incorrect. Then B is also incorrect. A is correct but it is not balanced, so we go for the one which is balanced, which is C. Question A16. The position of metal M in the reactivity series is shown below. So we know we have M at this position. Which method will be used to extract M from its holes? So we want to extract M. So there are basically two methods that are used to extract metals from their ores. These are the reduction of the molten metal compound. Then secondary is electrolysis of the molten metal compound. So now, how do we determine which one do you use? So the method that you use depends on the position of the metal in the reactivity series. So metals that are more reactive are extracted by electrolysis of their metals salts or molten ores. Then those metals that are less reactive than carbon, you use the reduction method where there is a single displacement. Then carbon, it replaces that metal from its ore by reduction, that is losing of oxygen. So the carbon forms carbon dioxide or carbon monoxide and reduce that metal. Now if you look at M is more reactive than aluminium, and it's ideally could be calcium or magnesium between those two elements. So these are reactive metals. These are more reactive metals, and this one we use electrolysis of their aqueous molten oxide or ores. So what you notice in this case is A is the correct answer. So take note of the two methods. Question A17. A gas X was passed over a hot solid Y using the apparatus shown in the diagram below. So we have gas X, solid Y, then we heat that solid Y, then we are going to pass into the lime water. At the end of the experiment, the color of Y had changed from black to pink, and a white precipitate formed in the lime water. What could be X and Y? So we have X, carbon dioxide, Y, carbon, B, X, carbon dioxide, Y, copper, then C, carbon monoxide as X, then Y, copper, then D, carbon monoxide, then Y as copper oxide. So what is happening in this case? This lime water forming a white precipitate, which is the calcium carbonate. So if this is lime water, this should be calcium carbonate. So what is going to happen is we are having the copper oxide. So copper oxide, which is solid, is reacted with carbon monoxide to do reduction, just like the question that we are from talking about in question 16. So what is going to happen is we are going to have the copper solid, which is the pink solid, then plus carbon dioxide, which is the gas. So now this carbon dioxide is going to be passed in lime water. So we are going to have now carbon dioxide, which is gas, is going to react with calcium hydroxide, which is the lime water, which is aqueous. Then this is going to give us calcium carbonate, which is the white precipitate that we are going to see, which is the same solid, then plus water, which is liquid. So what you notice in this case, this is copper oxide, which is copper to oxide, then plus carbon monoxide to give us this calcium carbonate and water. So the correct answer here is in D. Question A18. 3 reactions involving ethanoic acid are represented by the letters X, Y, and Z as shown in the figure below. Which of the reactions X, Y, and Z involves oxidation? So the first question that we need to ask ourselves is, what is oxidation? So oxidation is a chemical reaction that involves the gain of oxygen. Then on the other hand, we have what is known as a reduction, which is the chemical reaction that involves the loss of oxygen or the gain of hydrogen. Then in oxidation, we are gaining oxygen, but we are losing hydrogen. That is the oxidation. Now we are dealing with ethanoic acid. So what we are asked is to identify which reaction involves oxidation. So we are coming from ethanol to ethanoic acid. So now what happens is alcohols are oxidized to form carboxylic acid. When you react alcohols with oxygen, they will give you carboxylic acid. So what will happen in this case at X is going to be like this. We have ethanol, which is this. Then we are going to react it with oxygen. Then what we are going to get is we are going to use a catalyst to carry out the oxidation. So we are going to get this acid plus the steam, which is water. So this is how we are getting to ethanoic acid. So this process we are adding oxygen. That's oxidation. So you notice that what you are going to see in this case is at X there is oxidation. Then when we react ethanoic acid with sodium, what are we going to get? So for us to get sodium ethanoate, we are going to react with sodium salt with ethanoic acid. This is, there is no oxidation here. We are not adding oxygen. We are doing double displacement. So Y is out. So whatever there is Y is out. So notice that there is only one answer, which is A. So A is the correct answer. Question A19. The table shows the results of tests carried out on compound X. So we have the test and the results. So test, bromine water added, decolorization happens. So decolorized results. Then because of that, if you have decolorized results, this tells us this as a double carbon bond. So these are alkenes. So which is the double carbon bond. So double C bond. Then second test, sodium carbonate added, we get colorless gas evolved. So that colorless gas evolved is in hydrogen or water. Then which is can be steam. So this is an indication that this is a carboxylic acid. So the compound should have double bonds and should also have the carboxylic functional group. So if you look at A, it has no double carbon bond, so but it has this carboxylic functional group, so A is out. We look at B. B does not have the double bond, though it has this carboxylic functional group, so it's out. Then we look at C. C has a double carbon bond, but it doesn't have the carboxylic functional group. It only has the alcohol functional group, so C is out. Let us look at D. D has the double bond, which is meeting the first test. Then it also has the carboxylic functional group, which is meeting the second test, so D is the correct answer. Let us look at the last question of section A, which is question A20. butane and the methylpropane are isomers, which formula is different for the two isomers. So the first thing that we need to do is to understand what are isomers. So when we're talking about isomers, we're talking about different compounds which have the same molecular formula but different structural formulas. So we are saying isomers are different compounds which have the same molecular formula but different structural formula. So there are different compounds with the same molecular formula but different structural formula. So what is different is the structural formula. So you see D, the molecular formula, this is the same. So D is the correct answer. So this is how you answer the questions from section A to get the optimal marks. So thank you for joining me on this episode. Please join me in the next episode as I start looking at section B of this paper.